your first finite element example in NX. You open your NX, and in NX you open a new file. Look that you choose a folder that's really on the fastest disk. In my case it's an SSD. The name, that's just up to you what you take. And finally you click OK. Look that you have a model open. I just make a sketch rectangle from the 0 point on the XY plane in a size of 500 times 30 millimeter. Then I make an extrusion of this. The height is okay with 60. I have my first assembly. I save it. Then I go to application and choose here pre-post. You have a lot of application, and here in this area are the simulations that you already know the motion. Now I go into pre and post. The first step in pre and post is to make new FEM simulation. Take care that you have opened these two windows. I hope it's open, otherwise just double click down here if it's closed. And until now you have one file. If I click new FEM simulation, take note that I have this active, create an idealized part. Here I have all visible, standard, geometry option the moment you leave it, and then the solver we use is SimCenter Nastran, structural, to no 2D option, so that's okay. Then you have a larger menu with a lot of possibilities. Normally it should be okay. Solution, SimCenter, Nastran, structural, none, and the solution 101. You have a lot of solution. Don't choose another solution. We just start with the basic solution typesets. Solution 101, linear statics. Then you click OK. You can look at these different areas, but everything until now is we do OK. And as you see, we got 4 files. In the moment they are not saved, they are just in the main memory. We are now in the FEM file, and if I change to the sim file, you see it's blue. We have also another menu type up here. In the sim there are the simulation specific things, loads and constraints fixations. In the FEM I have the materials and I have the measures. I start with the material. In here you find assign material. I click on aluminium, say this body is active. You see now it's okay. I can choose that this body is out of aluminium. I choose tetrahedral mesh. In this mesh menu, take care that you click the body you want to mesh. You say automatic element size. Look that these rulers are on 80, 50 and 0. Later just come on what that means if we are discussing meshing. And I make OK. You see now we have finite elements here in, and we find all the information up here in this browser. You information on this. So we see as an example here the number of elements and the number of nodes, just as an information. And you just click here, and on the right mouse menu you find all these engines. That's all we have to do in the FEM file. We have made the material connected to the body and we meshed the body. I changed the simulation file. The simulation file, I start with force on this face. I introduce 10,000 Newton, that's 1,000 kilo, a ton, in the direction minus that. I click apply and you see here are the forces. Load force. It's found here in, if I want to change, because I made a failure, I can change the figures or directions. Okay, I turn a little bit my piece so I see it on the other side, and I fix on this side, totally rigid, fixed and shown with this crosses. So everything is fine. We have made until now 4 things: material connected, meshed, force, the constraint. These 4 steps you have all the time to do. You have all time to make at least 1 constraint, 1 force. Now you are ready for solve. I recommend you to save all files. As I say, save all. So I have saved all my work. Now I start with solve. Just click on OK, and the solver is going on. It's going quite fast. It could be that you would be asked the first time that you give the right that Nastran is working. I say yes. I look at the different files, not really interesting for you. What could be interesting is this analysis job monitor. Just click on the analysis you made and click analysis job information. If you get this message, no error or warnings found in Nastran output file, you're a lucky guy. Just close all windows, and now here in result you find the different results. As a first result, we look at the displacement. You can animate this. The fastest way is just to play, and you see that's the deformation of this half a meter long beam is just a little bit more than 11 millimeter. You have this animate menu where you can change full cycle and perhaps a little bit faster moving, because you have really good graphic cards today. Perhaps a little bit more slides, and then you have a nice film on your screen. I just stop it, close, and I'm looking at the stress. You see where the stresses are high and no stress in this area, and there it will be stress. What's not possible is to see where it is compressed and where it's getting longer, so no difference, positive or negative stress, just a stress value. And a little bit strange here, you see that the finite element, the size of the finite element, has a large influence on the result. You just can identify result at the different nodes, so you get real good information where it has how many stress. The values in the area where it's fixed are really fast changing. That's a problem we discuss in the next chapter about here. Just 0 in the middle and large up and down. Should be about the same value. Okay, close. You leave the post processor and you're coming back to this window. I say save all. I close all windows. And now I'm looking what happened on the file side. Just in my total commander, you see these are the files just created in this presentation. We have 11 files. Each solution makes 11 files. So that's the reason I am working in a subdirectory, and the version of the files you have to know is that's the original part file, a modified, simplified part. Then you have the FEM file, the simulation file. Here are the meshes and the material. Here are the loads and the fixations that supports the constraints. The solution you find here in the OP2 file. So you have these 5 files. You have to save. All other files in the moment are not for any interest of you. How to restart? If you have done the work, you choose just a sim file, you put it in the graphics window, and you should have the following. The sim file now you see we have opened 4 files. I close it once again, close all parts, and I just return the sim file here and it opens. What's stranger in this type, it's only 2 files. What's missing is the part itself. So say double click and you have all 4 files. Okay, that's all. Try it yourself just with a simple beam on deflection.